In disc filtration, hydraulic capacity, active filter area, head loss, and long-term robustness are closely linked. Invent set out to rethink exactly that.
At Invent, we have always been drawn to engineering challenges, especially when fluid mechanics is involved. When business partners first approached us with the idea of developing a disc filter, our initial reaction was cautious. But the deeper we looked into the applications, existing products and their limitations, the clearer it became. There was considerable room for improvement. The starting point was not a shape, but a set of engineering rules. No welded connections, no clamped connections, no central shaft, no central tube, and an all stainless steel design.
Once those rules were defined, the solution had to follow a new logic.
These boundary conditions became the foundation of a patented engineering solution.
Our task was to translate these boundary conditions into a real machine concept. A structure that is self-supporting, robust, and manufacturable.
Stainless steel was never just a material choice, it was part of the concept.
The iFILT concept was conceived as an all-stainless steel engineering solution. Robust, durable, and built for demanding long-term operation.
Not an adaptation of an existing concept, but to design a different one.
The result was a structural concept in which the filter wheel became more than a support for filter media. It became part of the engineering solution itself.
The key idea was not a static filtration, it was dynamic filtration. As the filter wheels rotate, the filtration process becomes dynamic.
This movement creates the crossflow effect, more precisely, a tangential dynamic filtration effect at the filter surface.
That effect is the defining part of the concept. It increases hydraulic performance, and it ultimately gave the system its name, DYNAMIX.
Another factor also enhances the effect of tangential dynamic filtration. The optimized three-dimensional filter cloth that is woven with precise, robust, and corrosion-resistant stainless steel threads. In the first generation, the flow enters through a fluid mechanically optimized distributor pipe into the center of the filter wheel. Because this version is not submerged, it does not require a sealing system. This created a strong first design for tertiary filtration, compact, robust, and hydraulically efficient.
The first generation design was strong. The next step came from increasing hydraulic demands and from applications with limited available head. How can hydraulic capacity be increased while total head loss is reduced? We did not just refine details, we rethought the hydraulic guidance itself.
In the iFILT-S version, the distributor pipe is no longer part of the concept. Instead, the inflow is guided through the inner section into the deeper submerged filter wheels. This new geometry required a sealed design. A key step was the new wheel geometry. By increasing the filter wheel diameter and enabling deeper immersion, the active filter area was significantly enlarged.
This led to the iFILT-S DYNAMIX Disc Filter. Dynamic filtration, more active area, deeper immersion, lower head loss, and higher throughput.
As the hydraulic resistance rises, and with it a rise of the water level within the filter, a backwash cycle is automatically triggered. The spray nozzles clean the filter fabric from the outside using filtrate. Thus, an external water supply is not required. The removed solids are flushed into an internal collector's flume and can be reintroduced to the wastewater treatment plant's cleaning cycle. The filtrate is drained off separately. Today, iFILT DYNAMIX disc filters are used in demanding municipal and industrial filtration applications, especially in tertiary treatment and water reuse.
In the end, performance is not the result of one detail. It is the result of principles, structure, and hydraulics working together.